I am excited to get to introduce the 2018 Hedges Lecturer, Professor Andrew Gelman. Andrew is the Higgins Professor of Statistics and Political Science at Columbia University and the Director of its Applied Statistics Center. He is a distinguished scholar and has received numerous awards, including being named Statistician of the Year by the Chicago chapter of the American Statistical Association in 2014, and the Outstanding Statistical Application Award from the American Statistical Association in 2008. He has written 7 books, with at least 2 more on the way, and last year alone published 17 articles. For those of you on the tenure track, remain calm, only 10 were first authored. It is not a bit surprising that Andrew would be asked to be the Hedges Lecturer this year. In addition to being a brilliant statistician, he is a prolific writer, critiquer, and thought leader in the application of statistics to the social sciences. Andrew has written approachable, thoughtful pieces in mainstream publications like Slate, the New York Times, and others on a wide range of topics. More recently, he has led many of the discussions about the replication crisis in the social sciences, providing thoughtful critiques on both particular papers and on broader disciplinary norms. Andrew embodies the role of public intellectual and spokesperson for the field of statistics. I can very much remember stumbling upon his blog, Statistical Modeling, Causal Inference, and Social Statistics, in 2004 when I was contemplating applying to graduate school. I'm not sure that I understood exactly what he was writing about then, and I'm not sure that I do all the time now, but I do remember it giving me the impression that statistics could be a lot more than number crunching, that as the backbone of science, statistics was at front and center in our quest to understand the social world. Today, Andrew will be talking about connections between research design and the use of research findings, with an emphasis on this being a two-way street. I'm not sure about you, but in the current policy environment, I spend a lot of time wondering if kind of what I do matters. Are we studying the right interventions? Are we studying them the right way? Are principals and leaders really using our evidence to make decisions? If they aren't, is that their fault or ours? I very much look forward to hearing his perspective today, to the questions he poses, and to the new ideas he might have for us as a field. So please join me in welcoming our 2018 Hedges Lecturer, Professor Andrew Gelman.
It's a pleasure to be introduced by Beth, who is doing very important work on the design of studies. And one of the, I think, well, I'll just say, this happened several years ago. Some people in my office, they came in and they said, we want to design a study to do blah, 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 blah. And we want to know what to do. And I said, please don't ask me that. And they said, why? And I said, because people always come into my office and say, we have these data, blah, blah, what should we do? And I always say, if you'd only come in the design stage, I could have helped you, but now it's too late. So I said to these people, look, you should never come to me in the design stage, because then I can't say that thing that that we're always trained to say. And I think, you know, that's the principle that the design is the most important thing. That principle is so crucial, and this is what Beth does so much work on. So it's really a privilege to be introduced by her. I'll get back to this, but one thing I want to say is it's not just the design, it's the data collection, and I think that's underestimated. In statistics books, they'll have a chapter on gathering the data, and they'll have all this stuff about how you better do random experimentation, or otherwise we'll laugh at you because there'll be selection bias, and you better do a random sample, otherwise we're going to laugh at you because somebody back in 1936 did this survey, ha ha ha, things like that. But there's not much about, so there's a lot about the structure of how we gather the data, but not so much about actual measurement, which is really so important and somehow got missed. We had a discussion recently about how does social science differ from a field like physics. And one thing about physics is they're very serious about measurement. They've been out there, measuring things for hundreds of years, and they recognize its importance. Now, research and educational effectiveness, I just want to compare it briefly to social science in general, because I think we have some things going for us and then some extra challenges. So the big thing that we have going for us is that we're working on something important that everyone recognizes important. Now, that's also a challenge because we're trying to do better education, and everyone out there is already trying to do the best job they're trying to do. So it suggests there might not be a lot of low-hanging fruit. Whatever good ideas are out there, by the time they get to the experimentation stage, the news is already spread. And so it may very well be, as Beth pointed out to me one day, that whatever idea you're testing in the experiment, they may be doing in the control group. In fact, if you're doing a study, you get participations of a bunch of schools. Who are the schools that are going to participate? They're the ones who want to try new things. The teachers have the freedom to be able to experiment a little bit. And then they're going to compare your idea to best practice. So maybe best practice, they're already doing something better than your idea. Because meanwhile, your idea had to get improved and all that. And meanwhile, they're just doing it. So that's a real challenge. So let me say, to step back, I can't remember, we kept changing the title of the talk, but it was, at one point it was evidence-based policy is a two-way street, and the idea was that evidence-based policy is important, and it's sort of our job as researchers to harangue people and tell them that they're not using evidence-based policy, that they're out there using, divination and astrology and whatever ideas seem like a good idea at the time. They're not out there actually using the results of careful randomized experiments, blah, 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 blah. So I want to unpack that a little bit, and this comes up a lot in medical research. I talk about evidence-based medicine, and evidence-based medicine means three things, I think. And I think it's similar with policy. So the first is it means that your decision should be based on actual evidence, not just people's hunches. The second is, in medicine, they call personalized medicine, or in education, it would be adaptive education. That's a key part of evidence-based science, is that it be adaptive. And then the third part is that there's this thing called randomized trials, which are supposed to be the best kind of evidence. And often when people talk about evidence-based trials, evidence-based policies, that's what they really mean, is just that. There are some challenges with these. One challenge is that treatment that's applied to an individual is somewhat contradictory to the usual paradigm of the clinical trial, the controlled trial, is not merely that you have randomization, but also that you make a decision based on statistical significance. And that's somewhat counter to the idea of individual treatment recommendations, because as we'll get to, it's going to be very hard to get statistical significance on interactions. So there are certain contradictions there in the advice that's given to us. So that's the evidence-based policy. So there's some difficulties. I want to talk about the two-way street being that we need policy-based evidence. And what I mean, the simplest way of saying that would be that experiments should be realistic. But more generally, the idea that experimentation does need to have a closer link to practice, and that we have a model and it's sort of broken. And it's broken in social science, but there it's not even always clear what the goal is. But I think in our world it's sort of clear. The model is that you do a certain experiment that's about this big, and that experiment allows you to establish certain facts, which then you carry out into policy. So there's kind of four stages. So the first stage is researchers coming up with great ideas. Nobody knows how that happens. I guess they just come up with great ideas because that's their job. Then the second step is then people want to do some evidence, and so they pilot some study and check that you can actually do the great idea, and that the kids don't run out of pencils or whatever. Then the third step, so that's the great idea, it's here. Then you have the little pilot. Then you have the experiment that's about this big, where they do the experiment and they get statistically significant result, and it gets carried. And then there's the whole world here. Now, what's wrong with this picture? Well, a few things. One is it's not quite clear where the statistical thinking goes in. once you get the randomized experiment, you're supposed to just push a button and do some pre-registered design, so there's no statistical thinking here. Once it gets applied, it's being applied by these people who are like so busy, it's not like they're going to be doing a lot of statistical thinking. They're busy trying to clean the erasers at the end of the day, right? Then over here we have the piloting. Well, you can't do a lot of statistical analysis of pilot data. I mean, that's, as you know, statistical analysis of pilots data is a mug's game, right? That's what suckers do. They look at the pilot data to see how big the effect size is. You're not supposed to do that. So then the statistical that must all go into designing the treatment, the new treatment, right? Well, where did that come from? How did they come up with it? Well, they must have analyzed some data from what, though? To come up with a new treatment, at the very least, it's like coming up with a flavor of treatment. You have to figure out not just to do something, but how to do it. So how do you decide how to do it? Well, I have this randomized experiment, which was just big enough to establish statistical significance. If you're lucky, it's just big. I can't use that to figure out what the treatment should be. I can't use the pilot data. We already discussed that. So I guess I have to use the data from everybody else, except that's all observational data that never got collected anyway. So something went wrong. Well, I mean, it's okay. If everything's working, it's fine. But when things aren't working, then you want to step back and say, well, it's kind of amazing it could have ever worked at all. What does that mean? How can we even think about this? Now, where I'd like to be is for these people to be doing experimentation. I would like for all the teachers to have enough resources so that those who are interested in doing experimentation can do that, and then we can have these better databases. And in the health world, there's a lot of data, but it's often these weird things like Medicare claims data and like strange things. But where I'd like to be, now I don't know where we're going to be, but what I'm saying now is, like, I don't know how to do all this stuff, like how to give, 2 million teachers a little bit more free time so they can experiment, blah, 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 blah. But like, right now it's considered the ideal that this weird system where the idea comes from nowhere, then it gets piloted, then there's the little experiment, then they do it. So we're in a situation where even if everything were done perfectly, we wouldn't have the data needed to really evaluate and come up with better ideas. So that can't be right. It can't be right that our ideal situation is so wrong. But now, since I'm like gonna downer, let me continue with that theme. So why do I care about research on educational effectiveness? Well, I mean, I'm involved at all levels. I'm a parent. I used to be a student. I'm a teacher. Education, I care a lot about educational effectiveness all the time. But I don't, well, as a parent, as a student, and as a teacher, setting aside my role as a researcher, I don't do a lot of research on it. So like when I'm teaching, I've been teaching statistics for 30 years, right? So I'm always trying out new ideas. Well, let's go through the steps. The new ideas, where do they come from? I don't know. I just sort of try stuff that people told me. Well, at least I evaluate it. Well, no, I don't do the randomized trial. Well, it's not just I don't randomize. I don't have the treatment and the control. I mean, I don't even do two different things. Remember, like that's controlled experiment. People always like randomization's the glamour boy, but what's important is the controlled experimentation. A randomized controlled trial, it's the control part. I'm not controlling it, I'm just like doing stuff. So like you can forget about balance between the two groups because there aren't any two groups. But then you're supposed to do a pretest, right? So every year I feel like I'm gonna do a pretest at the beginning of the semester, but I never do that pretest at the beginning of, well, I mean, do I want to spend the student's time? Well, that's fine. Like, as a teacher, I don't want to waste anybody's time on a pretest. But as a researcher, I'm like, hey, you over there, you're doing a study. Okay, the first thing to do is fill out these 80 forms. Oh yeah, that's their time. It's other people's time. OPT, right? Don't worry about that. Okay, well, okay, no pretest. Well, okay, then it's harder when I'm doing my post-test. Oh wait, I don't have a post-test. I don't have a standardized test. I just like come up with the final exam like 2 minutes before I need to give it out to them. And I'm just like everybody else, right? Oh, but then I don't even have a definition of what my treatments are. So my ideal analysis, I'm regressing Y on X, I'm Y on Z controlling for X, except I don't have Y, I don't have Z, and I don't have X. And so, but maybe I could like do some sort of non-parametric model. Okay, so why? It's so important. It's so important. And we've been trained, right? We've been trained to say, like, I can't say, oh, well, why am I not doing randomized controlled trials here? Why am I not doing statistics? I'm not allowed to say, oh, well, that's because this is too important for statistics. Statistics is for things I don't care about, you know, like some psychology research, whatever. This is like important, this is important. No, we've been trained to say it's the important times. Those are when we should be doing all these. So why aren't we doing them? Why are we not practicing what we preach? Because it's hard, it's a lot of work, right? I want to spend my time teaching. I don't want to spend my time doing all this stuff. Oh, but by the way, all of you, you should be doing our latest. Okay, so, you know, it sort of bothers me that I don't apply these. So, presumably, although I don't do it myself, like, you know, there's other people should be able to do this. There's some idea that there's like safety in numbers, right? Like I'm teaching classes which are kind of unique. I personally, I mean, no joke, I feel like I don't really care what my students learn because I feel like the point of my teaching is just to help me write better books because the greatest good of the greatest number, just like, you know, people in our medical experiments, who cares what happens to them as long as you save lives in the future. How do you make a balance? How do you balance that? There must be a cost benefit. Like here's a new treatment coming up and there should be some horizon, right? Like how long is it even going to be used? This trade-off between how long do you run the experiment before you say, well, now I'm really convinced the new idea is better. I think that this should be done using some cost-benefit analysis. Not always, but I would love it if there was at least one example of anybody having ever done that once. I think that would give us a lot of insight, and we don't really have that yet. So I think that's something missing, actually. Now I want to give you I want to mention an example. This is a study that maybe some of you know more about than I do, and I thought it would actually be good in some way, because if I'm trying to illustrate general principles, it's best to illustrate a general principle, an example I don't know anything about. Like if I were to talk about political science, then I could kind of cheat and use my subject matter knowledge. So here I'm going to talk about something I know nothing about, which was early childhood intervention. So a couple of years ago, a paper came out. Some economists did a study in Jamaica of 100, I think it was 130 kids, and they were 4-year-olds. And half of them got early childhood intervention and half didn't. And the early childhood intervention, I think, was some weekly meeting with the children's mothers. And then the other half, I guess, got, you know, the usual leaflets and jars of candy or whatever kids in the control group get. They followed up the kids for 20 years. So the study began a long time ago. And then they followed them up and they measured how much money the people were making. Oh, their earnings. Earnings is econ jargon for how much money you make. It's kind of quaint how it's kind of like in psychometrics, ability means your test score. And the first time I ever saw a talk in psychometrics, the person, blah, 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 here's ability on the x-axis, blah, blah, and it's like, ability, how do you know their ability? It's like, what? Yeah, ability, you know, it's an ability parameter, because I had never heard of this stuff before. And so, wait, do you mean ability, is that like their score in the test? It's like, well, yeah, not exactly, but pretty much. But wait, like, aren't you, like, you don't know their ability, right? So it's like, anyway, it was funny, like, ability. Yeah, it's their ability to do well in the test, right? So, yeah, if you made that money, you've earned it. That's the econ principle. So they found that the kids who grew up, they had the ones in the treatment group had 42% higher earnings, and the result was statistically significant. So it was not only was the effect statistically significant, it was large, because you've all heard how like statistical significance is not the same as practical significance. Well, 42%, that's pretty damn practically significant. It's practically huge. Well, the result was, you can get like a 95% interval. Of course, it excludes 0. So it's like 2% to 82%, you know, something like that. So when you look at that, well, I don't think it's 82%. The estimate had to be at least about 40%, or it wouldn't have been statistically significant. So it's kind of, it's not a noisy study. Like, income varies, right? And you can't do a between-person comparison on this. So it's just very difficult. So you can do an analysis of this and say, how large do I think the underlying effect would be? It's doubtful that going like a once a week little thing for mom when the kid's 4 is going to raise earnings by 42% later on average. Presumably it happened for these kids in the sample, but you wouldn't expect that to generalize. If the true effect were, say, 10%, which is actually pretty big intervention, pretty big effect, then this study is designed so that any statistically significant effect would be at least 4 times larger than the truth. So we called it a type M or magnitude error. Now so I guess what I'm saying is I don't believe that 42%, but I don't even believe the statistical significance in that there were a lot of choices in the data analysis. There actually weren't just 2 groups, there were 4 groups because some people got zinc, they're always like giving out zinc to people, and then I think that wasn't statistically significant, and then there were some kids who dropped out. No, it's hard. This was I'm sort of picking on this example because it was a very good study. So the challenge is, here is a study that was very good, high quality, these people really knew what they were doing, experts, no joke, I really respect these people a lot, using the best methods and a big budget study. 130 kids doesn't sound like a lot, but you're just not going to be able to do 13,000 kids of this. So this already was expensive. And yet what came of this? Well, we got an estimate that was so noisy I don't believe it. And even if I did, that would say, oh, we have a really good estimate of what would work in Jamaica 25 years ago. I mean, presumably, like, whatever they were doing then, like, what can you get out of this? Well, it has some propaganda value. So if you start by saying, look, early childhood intervention is a good thing, we should have more preschools and fewer bombs, and studies like this will convince, I mean, sure, maybe that's the point. It's not, but as from a sort of science perspective or a research on educational effectiveness perspective, it's not so, you're not getting you're getting almost nothing out of it. And this was a big, high-quality study, which makes you wonder about all the other studies. And given that we can't make it larger, what can we do? So that's the big question hanging out there. This is a main effect, and yet we're sort of getting nowhere. Now, how was I trained? When I first took an applied statistics class in 1985, I was told that in causal inference, you don't need to know how the treatment works. It's a black box. It's magic. And magic was that's an insult. It was like a clever idea. You can prove the treatment works. You can estimate the treatment effect without knowing how it works. It was kind of amazing. Also, we were explained that you don't need to have a random sample. Your treatment people in your experiment don't need to be a random sample of your population. So that was kind of all amazing. But it doesn't seem to work so well. And so, like, what's going on? What's happening with this black box? Well, one thing is, if you don't know how your treatment works, it's unlikely, if you're just like coming up with treatments out of nowhere, it's unlikely you'll get effective treatments by just like shuffling things around. So obviously the treatment isn't a black box to the person who designed it. So you're leaving a lot of information on the table. Now, how to analyze the intermediate information is tricky, right? I'm not saying, oh yeah, they should have just done a path analysis, whatever, something like that. But there has to be a way to do this. So I also do work in pharmacology, and there you take these intermediate measurements, and that's part of your model. And I think that's necessary. Now, I had an interesting experience a few years ago. I got this email by a psychologist because I criticized an experiment by saying something like, well, I said something jocular like, well, say what you want about this experiment. At least we've learned something about the very important group of people of psychology undergraduates and mechanical Turk participants. We need to know a little bit more about those people. And he emailed me and said that you made an elementary mistake that my freshman students make, which is to think that you need to have a representative sample in order to do causal inference. So from that message of his, I coined the phrase, the freshman fallacy. And the freshman fallacy is the fallacy of thinking that just because a freshman says something, that it's wrong. But it's subtle. If your only goal is to estimate the main effect, that indeed you don't need well, let me say this. If your only goal is to estimate a main effect of a constant treatment effect, then you don't need a representative sample. However, if you have interactions, you need a representative sample. And in fact, if you have a treatment which is positive for some people and negative for other people, then you definitely need a representative sample. Now, presumably early childhood intervention is always good. Not bad for any kids. I mean, there might be some rare kids who, because they get the early childhood intervention, they decide not to study. That must be pretty rare. But yet, I guess then it just moves the question to cost effectiveness. If it's a good idea for everybody, why aren't people all doing it? It must have a cost. So if you care about cost effectiveness, then you care about estimating the treatment effect accurately, which means if you get something that's statistically significant, but you're overestimating the effect by a factor of 4 or 40 or 400 or 0.4, whatever, then that's not that helpful. And once we get to cost effectiveness, as you all know, the question is not does the treatment work, but where does it work? Where is it cost effective? And so you do care about these interactions. Now, I also had an interesting, one of the people who was involved in the early childhood intervention study was defending a different study, but that was criticized on similar grounds. So basically people said, I don't think the effect could be so huge. And he said that given the amount of variation in the data are so noisy, I'm not quoting him exactly, but basically, the data are so noisy that it makes it even harder to get statistical significance. Therefore, the fact that we got statistical significance is even stronger signal. Now I refer to this as the what does not destroy my statistical significance makes me stronger fallacy. Now, when stated this way, it sounds pretty silly, because of course I'm talking about somebody else saying something that I disagreed with, right? It would be a little bit like me describing a picture of someone you've never met and saying, hey, he looks really funny in that picture, and you could, all laugh. But this is actually a very common mistake. So it goes like this. We're designing a study. We want it to be big enough so that the noise is small compared to the signal. So that's completely, people talk about high power. I don't like to use the term power because it's focused on statistical significance, but we can all agree that we'd like to design our study so the noise is small compared to the signal. The noise is never tiny compared to the signal, because if the noise is tiny, you start to look for more signal. So you'll basically go until you've reached the level of the noise. But what happens once you get the data? You get the data and you find something statistically significant. At that point, there's a temptation to retroactively feel that you must have had enough power, you must have had a good enough design, which is what this person did. And the reasoning, indeed, is that the crappier your study, the harder it is to get statistical significance. Therefore, if you get statistical significance, you must have had a really big effect. In economics, this is called instrumental variables. Right? Because you divide by the thing. So the weaker the instrument, the more you divide by it, so you get a bigger effect, right? But it's kind of deterministic thinking. Really, it doesn't work probabilistically, because probabilistically, there is the chance that maybe what you're seeing could be explained by noise. So what went wrong? I mean, do statistical models have an expiration date? Like, what happened? Like, those guys in the 30s, like R.A. Fisher or whatever, like, when they were, like, developing all these methods and, like, winning World War II using statistical approaches, Wald, all these people, they were smart critters. They had these methods. Now, we're using the methods they developed, and they're not working. And what's happening. So I think what's happening is those statistical methods by Fisher and Wald and those people had implicit requirements. And a lot of methods have implicit requirements, and it's not always written, or it's written in mathematical language that we don't understand. Let me just give you an example. Suppose I tell you I'm give you directions to a certain restaurant and say, well, what you do is you walk 15 blocks east, then you walk 6 blocks north, and then you're almost there. Then you ask someone for directions, and you get there. Okay, those are good directions. What's the implicit requirement? The implicit requirement is that the streets are safe enough that you're not going to get mugged on the way over. Otherwise, there are terrible instructions if you're going to get mugged. You go like 4 blocks, and that would be it. Now, classical statistical methods implicitly rely on large effects and high-quality measurements. Now, a lot of times people don't realize that because they say, well, if a large effect, well, high-quality measurement, that's great. What if you have a small effect and low-quality measurements? Well, there's this little thing called n, or in this case, a big thing called n. Okay, big enough. The square root's big too. You can discover anything. So why is large? And you'll see this. People say, "Oh, that study was so bad. It only had n equals 43, whatever." I don't know about that. N equals 43 can be fine. Why is large n not a good general solution? Well, there are two things. First, when we talk about small effects, suppose you have a study and the effect is like, I'll just sort of make up a number, like 0.003 on some units. And so then we do such a big n that our standard error is 0.001. So then it's statistically significant. Well, I'm not going to talk about practical significance and all that. Maybe it's important to know that there's a real effect. Okay? So, because often if you find anything, then later you can tune it and distill it and make it stronger. Fine. But if it's really 0.003 this year, maybe it's minus 0.002 next year and plus 0.001 the year after that, or different in different states. There's no reason to think that a small effect will be in the same sign. It can vary. The second, so that's the other half of the n, is the idea of reducing the residual variance, right? So it divides by square root of n. But here the problem is that there's bias. Right? So we don't think too hard about measurement bias, because usually their biggest concern is variance from person to person. But if you take enough measurements and then divide them, the bias isn't going away. And if your bias is larger than your effect size, then again, it's not going to work. I really want to focus on. I think measurement is just so underrated. Which brings me to psychometrics. So it's education research, there's the psychometrics people and the policy analysis people, sort of. So you're all the policy analysis people. But the psychometrics people, we have a lot to learn from because they are focused on measurement. They talk about reliability and validity, which isn't even in most statistics textbooks. I would like to argue that psychometrics actually is research on educational effectiveness at a micro level, right? Because psychometrics is like, it's very basic, like item response theory. That's like, how effective was this test item? Or how effective is what I was teaching? Here are these test items. Was this lesson effective at teaching this, this, and this? I think it's the same principles. It's the same study. Educational effectiveness and psychometrics are the same thing. They're just on different scales. And I wonder whether, if we think in policy analysis, if we could do better if we could learn a lot from how they do things in psychometrics. So what am I thinking of? Well, micro-level treatments. So the idea that you're aiming to not just, so the basic psychometrics is, oh, somebody took my class, and then what's their grade on the final exam? But we can do a lot better. Our friends at Educational Testing Service can do a lot better by saying, well, if we teach this particular thing, how much are they learning this lesson? What are the correlations between these? Micro-level outcomes and mechanistic models, test lits and all these other things. Moving away from the black box. So we do have methods. Like, we have methods in our profession to do these things. I want to briefly mention selection. So one thing you hear a lot about lately is forking paths in data analysis, or p-hacking. It's in the news. I don't like the term p-hacking just because it's like you're accusing people of something, which I don't like to do. And also, conversely, when people say, well, I didn't do any hacking, and then they think their analysis is okay, even if it isn't. But like, there is an issue that except in very rare cases, we can find statistical significance or more generally successful seeming results by doing analyses that are contingent on the data. And that's something that it's a real issue, but I think it's overplayed. And I used to talk more about it myself. I think it's overrated. And the reason why I would say this is that if every analysis you ever did were pre-registered, you wouldn't start like shooting out discoveries once a week, right? So like, methods such as pre-registration, what they will do for you is make it harder for you to get apparent success. But the only way you can get real success is with effective treatments and high-quality measurements. So I just find it a little bit indirect, like for people to say, like, like we're not going to win the war by, by not cheating in some way. So the existence of things like forking paths and p-hacking have allowed people to fool themselves into not working hard to do good studies. So that's important, sort of sociologically speaking. But fundamentally, that's not what's going to save us. So let's get back to the implicit requirements. The implicit requirement of classical methods is that the effect is large compared to that the effect is large compared to the measurement variability. Otherwise, you get a problem like what happened in that early childhood intervention thing, where the effect had to be, the estimate had to be at least 40% to be statistically significant. If you're in a situation like that, you're dead already. Okay? Lots of studies like that. We call them dead on arrival studies. You know that the data are noisy enough that you're never going to be able to learn anything interesting. Now, I argue that we're in that world for a couple reasons. So we call this the world of incremental improvements. So one thing that's already mentioned, which is the thing that Beth had explained to me at Columbia a couple months ago, that all your best ideas are already being done in the control group. Now, beyond that, like there's even kind of almost moral issues, like you shouldn't like have a great idea and hide it, right? Like you should let people know about it. If we're thinking incrementally, I guess I can use the projector here. So here's time. Well, we have the axes here. So we're sort of gradually improving. This is effectiveness and this is time. So things are gradually getting better. Well, it's sort of like zigzagging. Sometimes we come up with ideas that are worse than the old idea. It seems weird, but it can happen because, again, you're doing the new things, so you're not doing the old thing. But a gradual improvement. But how are things tested? Everything is compared to the control, right? So you're here, we're gradually improving, and you do an experiment, and once you get to about here, you can say, here, now I'm up here. And then you have to wait a while until you get up here. So you're doing this kind of jump forward, and that has some problems. So one problem is that you're kind of always below the line, right? Because you're always lagging until you have enough information to prove that your new thing is better. But also, you're kind of like putting yourself in a very awkward position because you're like, should I test the new thing? Not yet, not yet, not yet, not yet. Or else you do it right away. So we have this thing in statistics we call the Armstrong principle, which is named after Lance. And that is that if you put someone in a position where they make people promise more than they can deliver, they're motivated to cheat. It's like, I have this great idea, I have this great intervention. Can I test it? Can I test it? Can I test it? Well, I test it, and it's not great enough to show up using classical methods at a 95% level, but I know it's better, right? So then there's a lot of temptation to sort of bend the rules some way or another. Now, but it's worse than that. Because as I've already argued, we care so much about interactions. We care so much about who should get the treatment, not just, is this a good idea? They're all good ideas. We're sort of already past that stage. We're on the efficient frontier. If we're not on the efficient frontier in effectiveness, we're certainly on the efficient frontier in cost effectiveness, almost by definition, because people aren't doing something, they're doing already what they're doing. So to estimate interaction, well, if I can estimate a main effect so I have an experiment, half the people get this, half the people get that, and I get a standard error. I'm estimating the interaction, I'm estimating the difference between the two treatments in group 1 compared to the difference in group 2, and subtracting. So difference in differences, or however I'm doing it. That interaction, each group has only half the sample size as it had before. I'm comparing twice as many groups. What that means is my measurement variance goes up by a factor of 4. The standard error is doubled. So now, then if you imagine, it's sort of not unreasonable to think that in interactions typically about half the size of a main effect. I mean, that seems like a reasonable, like if something has an effect of 10%, then it could vary from like 5 to 15%. So if an interaction is half the size of the main effect and it's estimated with twice the standard error, then to estimate an interaction with the same level of significance you could estimate the main effect, you'd have to have 16 times the sample size. Well, we don't just have factors of 16 kicking around, you know. So we are in this incremental world. I think this needs to, we need to think more seriously about costs of making the wrong decision. So I'm strongly opposed to frameworks of type 1 error or type 2 error, because I don't think there are any zero effects. I think that just everything has effectiveness, and the effectiveness varies. We now are supposed to be in this, conventionally we're in this world where we are kind of supposed to be conservative, do what worked before, but then if something new happens that's statistically significant, then we switch to it. So what happens if you're not at the 95% level, you're only at the 94% level? You have to wait, like, sorry, I can't try this out for you yet. Well, in medicine, it's like a big deal whether a drug can be approved. But in education, well, someone could still try it out, but maybe it doesn't get recommended. So, you know, at this point, I should say, well, let's just try everything. But of course, it's tricky because there's a lot of entrepreneurs out there trying to push their methods, and you have to. So, we're kind of not in a good place right now. And I think thinking of aiming for certainty, I think, is a mistake. But then I think we have to be a bit more upfront. So here's a method, and we don't know how effective it is. Like, we kind of think it works. Here's some evidence through some people, but the data are consistent with it not working. That's the way it is. Like, every kid is going to learn in their own way anyway. I don't mean here we should throw up our hands and not do any studies and not do any experimentation, but I think we have to move away from the idea that the goal of an experiment is to establish it, put ourselves in a position of certainty. So what then to do? What are my recommendations? I think big picture, I think we should be moving away from the black box toward a psychometric approach to educational effectiveness. I think we want more granular data and within-person comparisons wherever possible. Almost all the treatments, like a between-person comparison would be like boys learn different from girls, okay? We do some research like that. But most of the research in educational effectiveness is doing this will help you more than if we did that. And sometimes you can do both things to each person, or even if you can't do both often you can do both treatments to each person in different semesters, but even if you can't, then at least you can have time series and strong before measurements. At a technical level, this requires more effort. So first, a lot of it is just better measurement. Now, I think we have to be more, like, you know, sometimes better measurement is as simple as, like, I do political science, is like asking people 4 different questions and averaging the response instead of just asking one. Now, I don't need to tell you all, in education, you can do multiple questions. I think there are these, like, things you have, like tests, you know, they fill in the circles, you know, with the number 2 pencil. So, of course, you know about that. So it's more like using our resources wisely, right? Recognizing we're already like ahead of the curve when it comes to being serious about measurement. But we have to continue to be serious about measurement. When we're designing our studies, we have to think of them, be as serious as the people at Educational Testing Service are when they're designing their tests. And I've seen a lot of studies where we give people, respondents, tons and tons of forms, psychology measurement forms, lots of inventories, and we never use it. I mean, this all happens all the time. It's like, hey, let's throw in this inventory, let's throw in this inventory. They get like 8 pages of forms, and then it's all done, and like, you never actually do anything with it. Like, it's like, well, that's not really respectful of people. So that's just work. At a statistical level, there's multi-level modeling to make use of, to enable us to study individual trajectories. Moving away from the expectation of or requirement of statistical significance, or the equivalent. Like, I'm not saying replace p-values by confidence intervals and then check whether the confidence interval includes 0 or not, okay? And I'm not saying, oh, replace it by a Bayesian analysis and check whether the 95% interval excludes 0 or the Bayes factor is more than 3 or whatever. I mean, it's the same, it's moving away from the deterministic thinking. Integration of research and practice, right? So having the research be more practice-like, but also allowing practitioners to be more participants in research. Now, it's funny, like when you think, why do people do a study at all? Like people participate in a study? I think often people participate in a study for like, there's two things that are not in any statistics book, but I think the two big reasons people do studies, one is direct service. Right? Like, I'm doing a study, I'm getting $1 million to do this experiment. Well, I don't know what's going to happen, but at least I'm, you know, teaching kids in these 15 schools some stuff. Like, that's not a terrible use of $1 million, you know. Whatever, I'm paying my summer salary and paying some graduate students, and I'm teaching a bunch of kids. Direct service, like, it is, like, so that's kind of funny, but, like, that makes you sort of think about the integration with practice. If one reason we like these things is because we're directly educating people. The other thing is just advocacy, right? So how many times you hear people say, we're doing a study to prove blah, 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 blah. That's not very scientific, right? We're doing a study to prove. I'm gathering data to prove what I already know, except that maybe the data will show that I was completely wrong. What does that mean? These things are like, oh, I'm doing a study with 80% power. Now, that means that I know that the effect size is at least this big, like 2.8 standard errors away from 0. Well, I already know that, so why do I need to do the study? Well, I don't really need to know. I don't really know it. It's 80% power conditional on the effect size. When you're writing the proposal, you're acting like you know it has 80% power, not just conditional on the assumption. So you don't really know that. In fact, you know, these things aren't really working out at a level of 80%. So like all these things are kind of screwed up. So I think advocacy is fine. It's just sort of maybe should be separated a little bit from science. So you could say that we shouldn't be using medical clinical trials as a model, except probably they shouldn't be using medical clinical trials as a model in medicine either. So I guess I would like to conclude by saying what a wonderful position we're in, that we have a huge amount of expertise. We're working on something that we care about, and there's 3 million teachers out there who would like to teach better also. It's a huge untapped resource. Also, sort of, we're next door, disciplinarily speaking, to the psychometricians who I think we can use as a model for how to do better. So compared to, I think there are a lot of areas of the human sciences that are where it's not really clear exactly how to go forward, what to do next, and I think maybe in research and educational effectiveness, there are some steps forward that can help us.
So in the current political climate, how do we bring in the level of nuance and transparency, and we don't actually really know anything from a statistical standpoint? How do we gel that with also building public confidence in science and the progress of, or are we arguing that there really isn't any real effects that we can, because this was a really great conversation, a really great lecture, but I'm left wondering where we go from here with education research and with usable education research for practice.
Well, I guess for one thing, if we can make our, share our data, then like people can learn from the data what they want. I mean, I sometimes feel that like in many ways we'd be better off if statistics had never been invented, in the sense that then like people could, like what if you just had your data on no standard errors, and then people would say, oh look, it looks like the treatment helps in 8th grade. And then someone else says, but it hurts in 7th grade. And then people would have this discussion, and someone would say, oh, let's make a graph, like using different colors to show where it's helping and where it's hurting. And then you look at the graph, and in some sense, you're recapitulating the whole concept of hierarchical models. But we shouldn't, I think that in some way we shouldn't always be going around like telling people, oh no, you can't do this. Oh no, you can't make this comparison. So like not being certain doesn't mean you can't like try things out. I mean like the Warriors are the best team in the NBA, but they could still lose any night. That doesn't mean you can't say the Warriors are a great team, right? Like, so it's like this, like you can't, it can be liberating. So not having to be certain can liberate you to actually make more statements with the expectation. That's sort of traditional statistics. You make statements and you're wrong some of the time. It's just that, like, I think that people kind of forgot that a little bit.
Thank you for your lecture. I have a question on your assertion about leveraging all of the experimentation that could happen in classrooms. Excluding yourself, of course, because you don't have time, but others could do these things. How do you think about that in relation to psychometrics? So here I'm wondering whether what you have in mind are plan, do, study, act cycles, continuous improvement using measures that are very well defined, or what are you thinking about in practice?
I'm not sure what I'm thinking about. I just sort of feel like something could be done. I mean, one way of putting it would be releasing resources, meaning teacher time. I mean, my impression, I don't, my teaching load is kind of low as, compared to a typical classroom teacher. But my impression is that teachers and cops spend a lot of time filling out forms all the time. And that there's a lot of paperwork in those two jobs. And maybe it would be good to have less time required to, it's on one hand less time required to do paperwork and more time to do experimentation. Of course that would involve a certain amount of paperwork. I guess it's like, I don't know, I feel like it should be doable. That there should be a way, but I think the first step would be to sort of give respect to these people who are out there doing it. To say like if there are teachers who would like to be involved in experimentation and measurement, to give them the opportunity to do so. Because I feel like now, it doesn't seem like there's fully a framework for this. But I don't know, what do I know about that? Whatever idea I have about that, probably someone wrote a paper in 1974 saying empowering teachers to do local research, and they tried it, and so it's like we're always continuing to try things, and of course my own suggestions, I haven't applied the principle of evaluation to my own ideas, right? It's not like I said, well, here are the 12 things I think you should do, and here's some research showing that it's going to work. So we can get into that kind of regress, and I'm not sure. I feel like now, as I said, that we're in a situation where the ideal model has this compartmentalization, which I don't like. So if we could at least aim for an integration with research and practice, it might be a good direction. But how to actually do that without it being one more bureaucracy, I don't really have a sense at all.
I have another question related to that early stimulation study that you talked about in Jamaica. I felt kind of guilty hearing about it, because that whopping effect, that 40 percentage point effect 20 years later, really helped us sell a very similar intervention on a much larger scale in Bangladesh to the World Bank and Save the Children. And it actually, we evaluated it there in I think it was 120 or 240 communities, I don't remember, and found that it had big effects on nutrition outcomes. And there was actually we did sort of a little bit of that psychometric work where we try to link different mediating outcomes to one another, and it sort of basically was increasing the effectiveness of an already existing nutrition thing. Anyway, interesting benefit of basically what I probably agree with you was a crazy outlier result that actually the study wasn't designed to detect, and I think even the data wasn't designed to be collected. They just managed to find the IDs and match it 20 years later and find something. But what I would like your comment on is like, what do you do in a situation like that? Is this just an unintended benefit, or is it something where we should really say, forget about it, this is obviously not a meaningful finding, and just move on and not use it? I'm just sort of wondering what the value was of that Jamaica result, and the fact that it was published, and the fact that people made a big deal of it.
Yeah, I don't know. I mean, it does. I do feel like somehow the information in the study is weak compared to the prior. Like, see, I remember I had some discussions with people about this. I did correspond with the first author of the study, who did not reply to me, actually. Because I said, like, do you think it's an overestimate because it's a biased estimate? Like, and he didn't reply. But I felt, I don't know the answer. I guess I sort of feel like it's their responsibility. So I would like in a sort of Bayesian standpoint, I would like the authors to say, well, what's my prior on the effect size? I mean, how could it be 40%, you know? But then there's also, I wrote a paper on these type M magnitude errors where we framed it in a non-Bayesian way, where you can say, if the true effect size is this is how much this procedure will overestimate the effect size. And I guess I kind of would like the researchers to at least kind of commit to say, this is how big we think is a plausible effect size. And if the plausible effect size, if you really thought ahead of time that effects could be as large as 0.2, 20% or 40%, then sure, this does provide a little bit more information. If you really thought the true effect size could be less than 10%, then it's not really telling you much. And that is, I mean, that's the issue, right? It's it's a relatively big and it's expensive, the study, but yet it still doesn't tell you much, and that's just the way it is. So that's just maybe not an effective way of learning. That even though we've been trained to say the most effective way of learning is to put things into this laboratory setting, even a field experiment is really like, putting a laboratory dome in the field and acting like you're in a lab. That maybe that's just not the best model. But I recognize that if you were to go back 50 years, you could have had like Fred Mosteller coming up here telling you stories about observational studies that gave the wrong answer, and how we really need how a small experiment's better than, it's better to have like a sample of 100 good data points than 10,000 bad ones. So that would have been what you would have heard then. But yet, so this is really hard because the outcome is how much money you make, and that's very variable. If the outcome is something that can be measured better, then that's more stable, then you could do better. It's not the number of people in the study so much as like what things can be measured more or less effectively.
Thanks. This was a great provocative talk, and I'm hoping you can help me resolve sort of a tension that I feel, and it's something I've been thinking about for the past year or so with respect to working with community-based public health organizations, where they want to do pre-post studies. They want to sort of say, are our outcomes getting better over time? That is sort of what matters for them. I am someone trained in a very formal causal inference way, as you know, and so this is a tension for me, because then the causal inference side of me says, but that's not a causal effect. A pre-post design is a really, really bad way to estimate a causal effect in a lot of settings. So I'm trying to sort of resolve, like on one side sort of appreciate, yes, in reality, for practice, we often really just care about kind of continuous improvement. But then the causal side of me sort of pushes back. So I guess I'm just curious if you have any thoughts on that. And maybe the answer is not everything should or is causal, and that in reality we try to make more things causal statements than should be. But again, I'm just hoping you'll help me with my own internal tension that I've been feeling.
I think I told this before. One thing that helps me in figuring these things out is I have a little Jennifer Hill emulator, and I keep that somewhere back here. When I have these questions, I'll ask her. The funny thing is, I think sometimes when she has statistics questions, she has an emulator of me. So I guess if I really wanted to figure something out, I could ask her my Hill emulator to emulate me and figure that out. But no, I mean, in your case, like, is there no control group? I mean, because So, I mean, I think there's two things. I think before-after changes are good. Whether, like, if you don't have a control group, you definitely would like to see time trends and not just see after. Of course you want before. If you have a control group, then you want the before measurement also. So I don't, like, it seems to me like there's not a tension, there's just two completely different issues. One is that whatever you're doing, I'd like to have multiple measurements over time and model that for each person. The second is, yeah, I'd like to have a control group, but those are different. Like, so your causal thing, sure, if you don't have a control group, then you definitely need, you need more modeling. You need to make assumptions. But that's, I guess, why they don't want to have a control group is really the issue there that you have to think about.